Just so everybody who doesn't know, Lisa, where are you joining us from?
Oh, I'm from the San Francisco Bay Area. So yeah, it's about 6:45 in the morning, but that's fine. I didn't know sunglasses, and I'm not wearing a blazer or a tie either. But I didn't know
If you want to
that
wear
about
if you have some flower print swim trunks, that's also an option. But anyway,
maybe for the talk a little later.
that's okay. That's okay. Yeah, exactly. We're working our way up to that. So, Lisa, you found this phenomenal speaker that we're about to watch next. Who is this person? How did this happen? How do you find these people?
Yeah, Harsh is absolutely amazing. He's just been an incredible ambassador for technology, for open source technology, for CockroachDB in particular. He actually found us at a hackathon. It was Hacktoberfest 2 years ago, which is an amazing event. DigitalOcean ran this event that was helping people get into open source, work on their first commits. Just get started. And it was a great entry point for a lot of young folks. He was probably 13 at the time.
I was just gonna
And
say, yeah.
we were one of the sponsors. I got to meet Harsh in person a couple of weeks ago at the no, it was BitCamp at UMD, University of Maryland. And so he's just been really a good person for taking advantage of all of the assets that are out there, like hackathons, to get started. You can still be in high school, you don't have to be in college. They were virtual for a long time, so totally accessible to folks all around the world. So I just thought Harsh would be a good person for to talk to your community about how to get started in open source, and also just to be an inspiration, because it's never too early to start, and even to take on complicated things like distributed SQL architecture and running serverless on Kubernetes, and things that I was not thinking about when I was 15, but Harsh is definitely thinking about, and I'm very impressed.
Yep, I couldn't agree more. That being said, without further ado, you will be seeing Lisa later on today, folks. I just shared her Twitter in the chat on YouTube, so you can check her out, but she'll be back with us later for another talk. Great intro. So that being said, let's take a look at what Harsh has to say about serverless databases on Kubernetes. 15 years old, folks. So take this as a source of inspiration. If he can do it, you can too, all right? He's also in our Slack if you want to reach out. Anyway, wonderful person. So that being said, Gorka, if you can play the video.
My talk today will be on Kubernetes, which is the architecture framework for serverless databases. So we'll kind of be understanding the magic in the serverless databases, how do they really work, and why exactly they chose Kubernetes as their scaling model, so to say, for their database structure. So a little bit about me first. My name is Harsh Singh. I'm a serverless fanboy. I really love serverless, and I'm also a database nerd. I'm also a high school student. I'm 15 years old, currently in 10th grade. And here's just where you guys can find me across the internet: my website, Twitter, GitHub, my email, all that stuff. If you guys do have any questions, feel free to DM me on Twitter or shoot me an email. Both of them work. But let's move on to the different topics we'll be covering. So we'll first be looking at what exactly are serverless databases and the need for them, why they were initially developed. And then we'll be looking at the architecture of Kubernetes. How does Kubernetes actually work under the hood? We'll be looking at clusters and inside the individual Kubernetes nodes. Then we'll be looking at the architecture of a serverless database, understanding how they work, understanding how nodes work, and how they properly scale to meet demands. And then we'll just conclude everything at the end. So I want to first start by talking about what exactly are serverless databases. So simply put, serverless databases, they basically take the features from a traditional relational database like PostgreSQL, and they combine them with serverless architecture. So this basically makes interacting with your database as easy as using an API in the cloud, and it takes a lot of the application complexity out of hosting your own database. So in simple terms, you can design, build, and deploy your application without having to worry much about the infrastructure that's actually behind your database. And even though it's called database, I think the term's a bit deceiving, because in the end, there are actually servers. It's just that you don't have to worry about managing these servers. So your life becomes much, much easier. So let's move on to the need for serverless databases. And I have the three basic points up there, which is relational databases aren't really designed to be very scalable, and no SQL databases like MongoDB, they sacrifice SQL and data integrity to achieve the web scale that they have. And so the question is, why can't we have both? So the key word in all of this is initially people were having trouble scaling their relational databases, and what happened is they started adopting the NoSQL model to properly scale out their databases. And as I mentioned, they sacrificed crucial features that people needed before, such as data integrity, SQL referential integrity, to work out this web scale. And what happened is this put many people in a dilemma, which allowed for this radically new infrastructure known as serverless databases, which adopted the structure of Kubernetes to allow for easy scaling whilst maintaining the core features of a relational database, such as referential integrity or a standard query language. So now that we know about the structure of these serverless databases, let's talk about the structure of kind of Kubernetes, the architecture of it. So the key word people use when describing the architecture and design of Kubernetes is orchestration. And the example of an orchestra is oftentimes used to kind of describe Kubernetes. So in an orchestra, in my understanding of an orchestra, there's a conductor and there's musicians. And basically we can think of Kubernetes as the kind of the conductor in this orchestra. Basically Kubernetes orchestrates the infrastructure to handle different workloads, and it auto scales up and down when it needs to. So this segues into our next topic, which is clusters. And this whole system that I was talking about, scaling up and down, is essentially referred to as a cluster. Inside a cluster, there are several Kubernetes components, such as the control plane, which has several subcomponents inside it, and it kind of works as a control room, or as as a brain for the whole cluster. So this basically exposes the API server and interfaces to handle external or internal requests from the nodes and other components. And it also contains etcd, which is a key value store. And it's used as Kubernetes backing store for all cluster data. So in our example, the control plane here, it basically consists of several different components. So here, the API, the scheduler, etcd, and the control manager and the cloud control manager, these are all components of the control plane, and all of these components work together to interact with the cloud. This cluster also manages several nodes, as you guys can see, and each of these nodes communicate back and forth. Each of these nodes communicate back and forth with the control plane and the other nodes in order to efficiently manage the cluster. And as demands increase, Kubernetes has the capability of adding more nodes or adjusting things here and there in order to meet proper demands. And most of this comes with little to no management, as it takes complicated things out of this whole process, such as secret management or networking. You don't have to worry about it. And so you can just focus on building. So let's move on. Let's talk about inside these nodes or workers. So there's something called a kubelet, which is a primary node agent, which runs on each node. This basically helps communicate back to the main control plane. There's also something called pods, which here I've represented with the Docker logo. They're the smallest deployable units of computing, and you can also create and manage them in Kubernetes. So in the documentation, they compare these pods to a pod of whales or a pea pod. In the case of Kubernetes, though, these pods are a group of several lightweight, portable, and executable images containing software and all of its dependencies, the operating system or the different packages they need to install, what it runs on, stuff like that. So let's move on. now let's get into some of the technical, let's get technical into like some of the structure of these like serverless databases now that we know how Kubernetes works. So these serverless databases, they essentially operate on a multi-tenant architecture. And essentially that just means that multiple instances of different applications or the same applications, which are isolated from each other, operate within a sharded environment. And it's all safe because they're isolated from each other, and there's proxies and stuff to ensure that your data won't be used by other applications which you share like your tenant with. So as I mentioned previously, the architecture of the serverless databases in the cloud, they oftentimes revolve around many of the same principles as Kubernetes, and one of them is clusters. So these machines also have CPU, memory, and a key value store. And in the case of Yugabyte or CockroachDB, their product essentially boils down to like the key value store because they're like a serverless database, and they both use RocksDB, although I believe CockroachDB serverless recently transitioned from RocksDB onto their own key value store named Pebble a while ago. So that's pretty cool stuff. But back to my back to my topic. Essentially, such clusters, they use an architecture that's built around like a bunch of symmetrical interconnected nodes which operate like collectively and collaboratively to manage the cluster and manage the incoming requests onto the cluster. So these nodes are intelligent and they basically know how to manage themselves and to rebalance and like repair themselves, along with like appropriately responding to faults in the database. So to avoid downtime in general. So let's move on to the breakdown of a database node. So a node is essentially an individual instance of your database, and multiple nodes form a single cluster. So as mentioned previously, the structure inside these nodes is also similar to the structure of like the nodes in the Kubernetes system. Although I didn't mention it previously, as you guys can see, there's a proxy here. I didn't mention this previously, but there's a kubeproxy in Kubernetes, which essentially manages like the network rules on the nodes, and it allows like network communications to your pods from like your network sessions inside or outside like your cluster. So the proxy here has a similar function. So one slight difference here, considering it is a serverless database, is that instead of defining custom images or pods, serverless databases come pre-configured with pods such as like the proxy pod, SQL pod, storage pod to do all this for you. So now if you'd like, say that you want to query some data from your database, the proxy pod will simply like route your request onto the SQL pod, and then the SQL pod then in turn passes this onto the storage pod, which like pulls the requested data from the storage configured, like the configured cloud provider, which can be like AWS or Google Cloud. It pulls the like data from the cloud provider and sends it back to the application. So now let's talk about how these databases are actually scalable. So as mentioned before, Kubernetes allows users to horizontally scale the total number of containers as per the requirements of the application. And along with this, Kubernetes allows you to scale your cluster up and down based upon like the needs of your application, the requirements of your application. So and all of this, it allows you to scale your operation costs up and down due to the fact that you only pay for the resources you need. And serverless databases are essentially keeping those benefits in mind. And it's no surprise why they chose like a architecture that's similar to Kubernetes for building their databases. So this powerful architecture that I've talked about, this basically enables serverless databases to do some amazing things. And not only can they like scale up and down based upon your application needs, but they can also like detect where your most active users are at any given point and move data closer to them, improving response times. And you can even keep certain data pinned to like a data center or an individual machine for easy access. Along with the power of like migrating your data across these different platforms, so you can horizontally scale, adding more nodes or pods to meet your application needs. So yeah, that's all I have for you guys. I hope you learned something new from this, and hopefully you have a better understanding of how this architecture works, both Kubernetes architecture and the architecture of serverless databases. And this is where you guys can find me across the internet. If you do have any questions, I'm always available on Twitter, and I do check my email. So if you have any inquiries, feel free to shoot me an email. And that's about all I have for you guys. Thank you for attending, and I hope you have a nice day.